Here we are. We're going to finish off with a bit more detail about the light-independent reactions, which occur, as you see here, in the stroma, which is the liquid part of the chloroplast, also called the Calvin cycle or the Calvin-Benson cycle after the people that discovered it. And just to summarize, CO2 is actually involved here, and this is the only place where CO2 is involved in the photosynthesis, in the light-independent reactions. We use the ATP and the NADPH, which came from the light-dependent reactions. And what we do is we attach, or fix, as they say, using this enzyme Rubisco. We fix carbon dioxide to ribulose bisphosphate carboxylase, which is a 5-carbon sugar. And we end up with sugars. These guys are used and then recycled because they're now ADP and NADP. Again, they're going back into the cycle again to the light-dependent reaction to get recharged. And also in brackets there, you got new waters produced. So let's just have a look at that reaction sort of simply. So we'll call it the Calvin cycle. Now the reason it's called the light-independent reaction, they used to call it the dark cycle. And they thought, well, it's not really, it doesn't occur in the dark, but it's not directly dependent on light. So they called it the light-independent just to make it a bit clearer. So we've got the Calvin cycle, or I'll just put in light-independent reaction. And the very first thing we have is the carbon dioxide coming in from the atmosphere. So here you have CO2 coming in, and you've got this compound. I'm just going to do it, ribulose bisphosphate, and that's just its acronym, ribulose bisphosphate, okay? And that's a 5-carbon, so it's got 5 C's in the molecule, right? Now, one of the things that Calvin did, he wanted to see how this reaction occurred to create sugars. So he radioactively labeled the carbon to see if he could track it, carbon from the carbon dioxide. So we've got here the enzyme and ribulose bisphosphate carboxylase, Rubisco. They say it's an enzyme complex. And what you'd expect, you add 1 carbon to a 5-carbon sugar, you do your mass, 1 plus 5, should be 6 carbons, okay? But as it turned out, the very first thing that Calvin saw as a radioactive compound was a 3-carbon compound. So he reckoned that this is very unstable, you never see it, and it splits up immediately into 2 3-carbon compounds. And you'll hear in photosynthesis, they tend to call it 3C photosynthesis in normal temperate plants, because that's the first product. And that first product looks like the pro-golf association, but it's phosphoglyceric acid, okay? So I just put in the acronyms because, hey, couldn't be bothered learning the full names, but phosphoglyceric acid, it's a 3-carbon compound. And he detected that because it was radioactive, and he was able to show it because of its radioactivity on film, because it reacts with the film. And then other things happen here, other reactions, which we don't really need to know about in terms of what happens. You can look them up just as well as I can. But somewhere in here, in order to drive these reactions, you got ATP is used up in the reactions in order to make them go forward. So use an NADPH. As again, I'm just popping them in anywhere here, just to let you know that they do have a role to play, but you don't have to know where it is. You just know that, yes, these are required to drive the reaction because you're pushing it uphill, and these are like the little motors that make them happen, going against an energy gradient. But what comes out here at the bottom is sugar, right? And that's the important product. And somewhere along here, you've also got new water comes out of the reaction. As to where it comes out, you can look it up in the book, no problem, but I'm not going to be asking you questions about it. Now, what actually seems to be, you can imagine thousands upon thousands of these reactions occurring at once in big pools, the reactions are occurring together, so they're switching products and doing all sorts of things, but it's just like a big melting pot. So again, the key is that the carbon is fixed by Rubisco, it's fixed onto a 5-carbon sugar. It's a very unstable 6-carbon compounds form. You never see it because it just breaks up so quickly. So the first product is phosphoglyceric acid. You get a few other compounds produced, but eventually you get sugar out of here. But what the whole reaction seems to be mainly involved with is regenerating our 5-carbon so that it can then bind carbon dioxide. So this will turn maybe 6 times for every 1 sugar comes out. That's just by the by. So again, Calvin cycle discovered by Melvin Calvin, and carbon dioxide is fixed. Where does it happen? Don't forget where it happens. It happens in the stroma, okay? In the liquid part of the chloroplast. Don't get confused between carbon dioxide in the stroma and carbon dioxide anywhere else. The only place it happens is carbon dioxide is fixed in the stroma, okay? So that's it. Simple sort of showing you that we get sugars produced at the end, maybe some new water. And of course, when these guys are spent and used up in the reactions, the NADP plus the phosphorus and the NADP plus hydrogen, they're recycled back into the light-dependent reactions. As I say, these are finite. You don't actually have tons of those, so they have to keep being reused, okay, and recharged up. Okay, that's it.